All right, so continuing our journey towards fully understanding what the base 12 version of pi is, what it means, how it works. What I'm going to do now is introduce you to the dodecagon, the base 12 version of the dodecagon, although here we see it without an actual base, just drawn out on, well, graph paper. Basically, you can see there's an X and Y axis, and you can see it's not just one dodecagon, but a series of dodecagons, a repeating pattern, a 12-sided shape. And one of the things that makes this pattern so powerful is that all of the points that define it are actual lattice points. So they're all landing on spots where the horizontal and vertical lines are crossing each other. So the first thing I want to do before we continue looking at the dodecagon is to actually show you what we're going to be able to build with it. Here's a picture of a construction that I made last year near the end of 2020. And you can see it's a very large diagram. It's about 8 feet high and 20 feet long. And it's 15 rings of a pattern that in itself produces all the points that are needed to create 360 degrees. So that's going to be the next step on our journey, is me showing you how to use the base 12 dodecagon to create the diagram that generates all 360 degrees, or the perfect division of the circumference of the circle. Because of course from there we can continue dividing the circle more and more and more, and again eventually coming to the base 12 version of pi. Okay, so I want to just show you again, we're still looking at the difference between base 10 and base 12. So we're going to look back again at this base 12 or the dodecagon and see what the difference is on a base 10 or a base 12 grid. So here's what it looks like on a base 10 grid. You can see all those points that I was talking about that define the dodecagon, how they line up or what the relationship is to the lines that are the 1, 2, 3 on the X and the Y axis. So this is what it looks like. You can also see in the center there I have a circle that is the radius of 1. Just look at that as far as the relationship between the dodecagon and the base 10 grid. Okay, now we're going to switch over to the base 12 grid. And you can see right away that this looks different. Things line up differently. The relationship between the points that define the dodecagon and the points that define the 1, the 2, the 3 line up differently. All those points are landing on those lines. You can see that the circle with the radius 1 has a different relationship to the dodecagon, and it's important to remember here, it looks in these examples like the 1 got larger, and that's simply because we've kept the size of the graph paper the same. The little squares, the 0.1 in these examples is the same, so it looks like the 1 is larger, but remember, ultimately the difference between base 10 and base 12 is the 1 stays the same, and we're dividing it up into smaller units. So the dodecagon actually shrinks down and lands on the 1 in a way that it doesn't in base 10. Okay, so I think that's enough for this video.